Good afternoon. Thank you all for joining us after lunch. This panel is a roundtable on Earth Station Teleport Data Center service strategies in a multi-band, multi-orbit domain. As satellite communications continue to evolve with the proliferation of multi-band and multi-orbit systems, the need for robust, adaptable, and efficient Earth Station teleport and data center strategies have never been greater. So we have a couple of additions to our panel, so I'm going to start by asking each of my panelists just to briefly introduce themselves and their company. And we'll start with you.
Hi, my name is Travis Mooney Evans. I'm the principal consultant at Developing Infrastructure. We provide all sorts of commercial and governmental consulting, both in the channel and to hardware vendors and things like that. I've renovated one teleport, participated in the build of another two, so I know a little bit, maybe not everything.
All right, great.
Thank you. John?
Yeah, I'm John Yates, Managing Director of Theris Analytics Limited, and we've developed an AI-based algorithm which we can use for predicting outages at Ka band and QV band, which we use for either planning Ka band or QV band ground network or for operating it.
Great. Ian?
Hi, I'm Ian Jones. I've had a couple of different careers in the space sector. My early career was on the supply side, designing equipment for ground stations. I founded and set up the Earth Station, and I'm now working for a new company called IBNet, and we're looking to scale up opportunities in the ground station sector.
And Scott?
Hi, I'm Scott Mumford. I'm CEO for Global Comms. We are a ground segment as a service provider to the satellite industry, so we provide and build large antenna and satellite earth station systems at data centers around the world for access to HDS satellites or LEO constellations.
All right, great. And we'll stick with you, Scott, starting with the first question. What are the key challenges in managing Earth Station and teleport operations in a multi-band, multi-orbit environment, and how can these challenges be addressed?
The geographical distribution of it, to be perfectly honest. Sure, this is good sound quality. Okay. So obviously, multi-band on single site is here we go. So yeah, multi-band on a single site is obviously quite manageable. Obviously, depending on your Earth Station locations, but adding into that LEO or multi-orbit generally requires significantly more spatial distance between the assets. So in a lot of instances, they're quite isolated from where your main staffing points are. So there's a lot of remote management and remote access requirements for the management standpoint. So anything that actually requires physical intervention, getting staff to them to be able to facilitate any maintenance or repairs or upgrades, activations, and so forth has its challenges. More so in our environment because we build assets at data center environments specifically for products and services that are in country. So things like cellular backhaul, where regulation states that it's got to be in the country that it actually the voice is being transmitted from. So that means a lot of gateways built in a lot of different locations. So staffing that and obviously physically getting personnel to there in time is a very significant challenge.
Okay, great. And Ian, what are the challenges?
Yeah, I think I would answer something very similar in a way. If you look over the history of teleports, they've been built originally not in cities, but where they need to be geographically. That often you'll find a hollow in the ground where you can put antennas, and you make the people go to where the antennas are. So it becomes an issue of servicing the teleport. If, for example, you think about the something that we never ever think about, the whole global network of radio transmitters, ground stations that support aeroplanes flying around the world and navigating. Who knows where those transmitters are? It's just, somebody gets sent there to service them when they need to be serviced. And for the large part with teleports, it's fire and forget. As a teleport operator, we operate at gross margins that are potentially in the 90%. You want to have an antenna that just sits there and works and needs the least amount of intervention as possible. So it's trying to create an environment where you can do that. So I don't think it's particularly a large problem. It's a problem of land and land management in a sense.
Okay, great. And John, from Aetherius' point of view?
Sure. Am I? Sorry, I'm not sure if my microphone's on or not. Is it on? Oh, I'm on. Okay, yeah. So with regard to the geographic dimension of it, there's another added factor with the move to Ka band and QV band. And because of the sensitivity of these bands to weather, then you also need to take into account the historic weather, not only at those sites, but also the correlations with other sites. You might have a site that has really good historic weather, and then the diversity gateway has exactly the same weather. So it doesn't really make for a good diversity site. So you need to be looking at weather patterns over recent history, and then analysing it so the whole network has a good diversity from a weather perspective. And the other aspect that we've seen is that climate change is having an effect on network design. If you take some of the long-term statistical models over 10, 20, 30 years, they don't effectively not always take into account recent climate change. So we look at both aspects. We look at the traditional statistical models, but then we also use our AI model and take the last 5 years of weather data. And usually they correlate, but quite often we see some quite significant differences between the long-term approach and the last 5 years, particularly on coastal areas, which seem to be more affected by the climate change. So it's another angle that we need to look at.
Okay, and Travis, what are some of the challenges?
I think I would point out the big difference in physical and look angle requirements between something like LEO and traditional GEO. So, there's lots of teleports where you've got a fixed satellite service that you only need to look in one or two directions. And that means that your choice of location is easy. But I've participated in a number of LEO site selection processes. And the requirements for, basically horizon to horizon look angle at a certain elevation, and your antennas are only maybe 3 or 4 meters, and they're all on the ground as well, it makes it a very difficult situation. So the actual installation of the equipment is easy because it comes on a truck and just gets trucked off of it. But the selection of the site becomes much, much more difficult. And a lot of the traditional VSAT teleports aren't really appropriate.
Battery might be dying. How do the different frequency bands, such as C-band, Ku-band, Ka-band, and the orbital regimes such as LEO, MEO, and GEO impact the design and operation of data centers supporting satellite communications? And I don't know who wants to take that.
The environment makes a big difference. Obviously, you've got overlaps between your DBS transmission band and your KA receive band. So, you've obviously got to make sure that you haven't got, side lobe interference between your assets. A lot of the LEO operators certainly require, clean spectrum. So there's a lot of radio frequency interference surveys done prior to site commitment and build. So, that side of it's key. But I mean, in the traditional C and KU side of things, it's, obviously most of those are fairly, everybody's pretty well experienced with those, and you've got those running through your more traditional teleport infrastructures. But I think it's more as the bands are going up and becoming more and more sensitive, and the potential overlaps between the transmission bands and the receive bands that you really get the headaches there, and DBS and KA being the prime example.
Okay, anyone else?
Yeah, I think from an infrastructure point of view, because I've done some work on data centers as well, not as much as Scott has with the interaction with satellite, but the way he's doing it by putting your space assets on top of the data center makes perfect sense if the stuff you have is in the data center. Whereas, back when I renovated my teleport many years ago, getting a tail circuit in to the teleport, even though Deutsche Telekom was physically located on site, was nearly impossible. So guaranteeing that connection to AWS or to Telehouse in London, or wherever the peering point was actually really difficult and took almost a year. So those kind of interplays now between low latency data are really important for a lot of customers, and a lot of customers that you don't even think they should be important for.
I think that's having a big impact, especially with the LEO gateways, because a lot of those are located quite a long distance away from the data center environments in the middle of nowhere. So it's not just the last mile tail, it's diverse last mile tails, and the power infrastructure, and the security infrastructure, and the fact that you're looking at, in some instances on some of the LEO sites, shall we say, 40 to 60,000 square meters of space to be able to accommodate the look angles that Travis mentioned as well. So, you start to get into a whole array of technical issues for the time it takes to deliver those, and that's really, I think one of the key driving factors for site location is can you find that level of space with access to power and fiber infrastructure that's not going to take a year to deliver and cost millions of capex investment for fiber digs and the like.
Okay, John?
Just to reinforce as well what Scott said about, with the lower frequencies, it's well established, everybody knows how to use uplink power control, fade margin, and that sort of thing. But once you get to the high frequencies, the fade is just too deep. You'd need a 25-meter antenna to even give you some fade, which is completely impractical, both economically and just practically. But the other side to it is with the non-geos. For us, when we're doing a fade prediction on a geo satellite, it's fairly straightforward. We have a single path, and we can look at the fade predictions over that. But for a non-geo system, then you've got a continuously changing fade path. And so we've built models now which have a full 360 visibility with 180 degrees, so full azimuth and full elevation, which requires a huge amount of computer power. But the great thing about cloud services is that actually you just add more nodes. So the more we need, we can just add it on the cloud. So it's everything we do is cloud-based, and some of the benefits you don't realize at the start, but being able to add that computational power really helps for the non-geo services.
Okay, great. Ian, anything to add to that?
Yeah, well, I think that, on paper, there's a lot that makes sense about co-locating ground stations and data centers. You've got secure infrastructure, you've got potentially good terrestrial data connectivity, you've got redundant power, all of those things. And there are examples where it works really well. So, the Betzdorf site, for example, you've got a massive satellite operator and a huge data center. But how does that come about? That comes about with significant government intervention. And then you've got examples like AWS, who already have data infrastructure around the world and think, oh, right, we can build satellite capacity to go with this. But actually making that work in reality, AWS hasn't delivered on the promise that they came up with 6-7 years ago of putting this. And you have to ask why. And I think there are aspects of who are the end customer and what are you trying to serve with your data center? And I think you have to think back up to the space segment, to the spacecraft operator, and what is their business model. And what they don't want to do is give away their revenue stream, their revenue model to a ground station operator I think the fact that you've got terrestrial connectivity from your ground station, that data comes down from space and it goes straight out again to wherever it's going to be monetized. So yes, it's a wonderful goal to come up with that. And I think the solution to the problem there is to have your own means of monetizing the data coming from space, and that's the challenge, I think, for a ground station operator.
Okay, great. What role do software-defined networks and virtualization play in optimizing the integration of teleports and data centers across different orbits and frequency bands?
Ask the question again.
What role are software-defined networks and virtualization going to play in optimizing the integration of teleports and data centers?
Yeah, it's almost the same answer in a sense, I think. Software doesn't cost anything, does it? And we all know that. And it's the answer to everybody's problem. And not only does it not cost anything, but you can sell the products from it multiple times over and scale up. And therein lies the problem. How do you get everybody to work together in a disconnected, complex world where everybody has problems? So yes, I think it's the $64,000 question. How do you solve that one? Clearly, when I started in the industry, everything was done on hardware. You built electronic circuits, and there was discussion in the first roundtable this morning between FPGAs and CPUs, and I wanted to stick up my hand and say, what about CPUs? GPUs, sorry. GPUs have completely broken the Moore's law over the last 4 or 5 years. GPUs are 40,000 times more powerful than they were 5 or 6 years ago, not 8 times more powerful. So the potential is there to do in software what we used to do in hardware, and so there ought to be more flexibility in terms of what can be done. I think that's where we need to go. I think one of the problems that we've faced is where do you find those engineers who understand electronics, RF, GPUs, can do the programming, understand the systems, that can actually program this and actually make those systems integrate together.
Great.
Actually, Randall, if I could just add something to that, just a little bit of a tangent, but when I did electrical engineering, a few decades ago, you were an electrical engineer. But the engineers that we employ now, they're sophisticated programmers. They're very astute, and I can't imagine how you could actually survive today as an engineer without having some pretty sophisticated programming skills.
All right. How can how can teleports be future-proof to accommodate the rapid evolution of satellite constellations and emerging technologies like 5G and IoT services?
It's a great question. I think if everybody had the answer to that one, everyone would be happy. It's very difficult to be frank. The orbit really has a big impact on that as to whether or not you've got the space and capability to be able to add that additional infrastructure into your existing site. The MEO constellations are probably easier to add to an existing traditional teleport than the LEO side, unless you have acres and acres of space and the separation. But it's becoming harder. The networks are becoming more and more distributed. Like we said, I was chatting over lunch, and we were saying, the days of the old satellite architectures where, it was zones and hemis and cross-strap transponders is long gone. There's a few legacy birds up there, but they don't really do a great deal these days. Everything's gateway beams and user beams and hundreds of them and frequency reuse and so the architecture that supports access to that is much more distributed. So having access to be able to put the antenna infrastructure where you need it to be means that it's not in that centralized space. So staying relevant and providing that becomes more and more difficult. So it's a tough one for the teleport operators to be really honest, and not one I envy them on. But certainly on the broadcast side of things, I think there's still a lot to be done there. Certainly for the next however long, but obviously even that's changing with the move to streaming and so forth. But necessity is the driver of invention. As things become more and more problematic, they'll find ways to evolve. I don't think anybody's got a final answer to that one yet, to be honest.
Ian?
Yeah, I think we all need to have the sort of COVID pandemic mindset in this, and it's very difficult to do in in our day-to-day work to think about what is the scenario that's going to come along and take our business away. But it's really important to at least have a portion of our time dedicated to how we can diversify and how we can do different things. It's really important. Otherwise, as we've talked a lot today, change happens, and when it happens, it seems to happen at an incredible pace that takes people by surprise. And so having some thought to diversity and other options and implementing that is really important.
All right, great. I do have more questions, but I do want to open up to audience questions. If there are anybody has a question, please raise your hand. No. All right. What strategies can be employed to ensure seamless connectivity and data flow between teleports and data centers? Travis?
Yeah, I mean, the basics are still the basics, right? So how do you connect, and do you have redundant paths, and are they in different trenches so somebody doesn't dig a backhoe through them, and what's your last mile connection third fallback, right? So these are old problems that we've had to solve years and years and years and years. The problem is that if you're in a remote site especially, the data volumes are so much higher than they used to be. And you can get your optical switched out maybe from 1 gig to 10 gig, but what happens when you need to go to 100 gig or you need to go to a terabyte? Like this is new trenches these are months and years to procure in some cases. I remember when I started with a dial-up ISP here in the UK, like in the end of the 90s, and we had a call bank in Cheshire, and it was in an old farmhouse, and there was an STM1 that came into the farmhouse, and then there was a 34 megabit microwave link that went out whenever it rained. And guess what? The STM1 was saturated, so whenever we got the rain in, nobody could connect to the internet. And that's the kind of problem that you try to find a short-term fix for like that, and then long-term, you've got a bigger problem. It could also be, though, that maybe the LEO network goes both ways. So you could trunk out over the LEO network and then go over intersatellite link or something like that into a different landing station, possibly. But that requires the platform owner to be amicable to the situation.
It's also diversity of access on top of that. So depending on your customer base and which cloud service provider they're using, they may be in different data centers. So you've then got to have routes to different data centers to be able to access those cloud on-ramps as well as that. So, the increase in availability of services is a great thing, and that's driving competition, driving down cost. But as a teleport operator, if you've got AWS in one data center and Microsoft in another data center and Google in a third data center, and you've got customers that require direct cloud on-ramps to each of those, you've got to have them multiple links going to each of those data centers. So your operational costs go up, as well as the infrastructure costs that go up to be able to do those. So it becomes a law of diminishing returns to a large degree on that side. I think one of the things Travis just said, which is, I certainly looked at in my previous life, was how you leverage non-geo satellites for data resiliency to sites, because if you've got access to those assets anyway, it makes a lot of sense to be able to leverage the return capabilities of those for yourself, rather than just providing it as a service to the operator and a customer. And we were talking specifically on the MEO side around data center redundancy and how you get high capacity links into data centers. Obviously my past life, we did a lot in Africa. So there was, it's been quite widely reported about subsea outages and countries going off the air for 4 or 6 weeks. Obviously, if you had a satellite backup to that, should the subsea fiber go down, instead of the country being off air for 6 weeks, you can then leverage that infrastructure to be able to do that. But the satellite operators need some arm twisting around their commercial approaches to do that, because they still want to sell you megabit services on year leases when you might only need it for 3 months. So it's a chicken and egg scenario on that one, between risk and commercials that sit on the back end of it.
Okay, great. Ian, I'm sorry.
Yeah, I think, a satellite operator that shall remain nameless, but we've talked about them a lot today. I know that on the one hand, they rely on the public internet, and the argument being that if the network goes down, rather than having one company saying, my MPLS is down, can you fix it please, and not getting much of a response, to have the entire public phoning up and saying, fix it now, gets a better response. So that's one way of getting resilience. The other way is to use your own network, essentially, or your competitors' satellite networks. But almost, is it worth turning the question round and saying, if we have this resilience in our ground stations, isn't that a product that we can use to provide to other people? And maybe that's our killer app that we have.
Okay, great. John, I'm going to turn to AI here. How can AI and machine learning be leveraged to optimize resource allocation and network performance across Earth ground stations, teleports, data centers in a multi-orbit domain?
Well, in a nutshell, extensively. But I'd also like, it's unfortunate, but when we talk about using AI, many people just associate it with ChatGPT and other stuff that you get on the internet, and probably 99% of people think that. But the real, the really useful stuff is the stuff that nobody talks about, and it's the fact that AI can take in hundreds, thousands, tens of thousands of data points and deal with it all and make some good sense and come out with a simple answer and say yes or no. So we use it from a weather context, and for a non-geo system, for example, we might be analysing hundreds of slant paths and long slant paths, as you mentioned earlier. They could be covering several weather systems over 20 kilometres. And we're looking at all that, and the AI just deals with it. And it's important to have it with the cloud resources, because you need to be able to throw cloud resources at it to support the processing. But you can come out with a simple answer that says, yes, that link will be intact, or no, it won't, which is just what you want. So we couldn't do what we do without AI, that's for sure.
Okay, Scott or Ian, AI and teleport performance?
Yes, so, well, I'm going to be doing a talk tomorrow in which I've leveraged some AI to help with my talk, and I can guarantee you'll find it amusing. Yeah, where can we use AI? Well, for a start, I think that our industry invented it in the first place, or at least, the tools, the digital signal processing and those aspects of it. And AI can be very hit and miss, but it presents itself as the definitive answer. If we leverage the physics-directed part, the digital signal processing, the filtering, the digital filtering that we all know we build into our systems, I think it's a very powerful thing that the industry has at its fingertips. We know how this stuff works. So leveraging digital filtering for your analysis, all of that type of stuff is really key to our business, and we need to use that, in terms of making decisions and automating some of the processes that we have in the industry.
Scott?
Yeah, I think just to reiterate, I think on the computational analysis side, and especially as John was saying on the antenna switching systems on the higher frequency side of things, KA, we've seen it obviously with diverse sites with 100-kilometer differences. I think once we get to QV, that's going to be even more prevalent. So data point analysis and the computational side of things for optimization of system performance, availability, throughput. That sort of analysis and how that can be applied is sort of a really strong leverage point that AI offers.
Yeah, I think there's an interesting point that I would bring up. Like at a previous facility that we used, there was one high-speed tracking, very large earth station antenna. And to switch it on took 70 kilowatts of power. So they never wanted to switch it on because it was very expensive to run. But with AI or machine learning or whatever you want to call it, a slightly less sexy application is, well, you know that the link is in jeopardy, and so it automatically comes on and automatically tracks to the correct satellite. And it can serve any number of satellites. So you could have contingency earth station equipment that is higher specification that will then give you link survivability. And I think that's a really interesting concept. And it's not like, everybody says AI, they think about killer robots. It's not about killer robots. It's about taking the stuff that's really boring and requires human intervention and making it automated and as cost efficient as possible.
All right, great. What are the key considerations for cybersecurity when dealing with a multi-orbit, multi-band satellite communications network? And how can data centers, teleports be secured effectively?
I don't think the band or the orbit has a great deal to do with any of that. But to be perfectly honest, I think, as we saw with what happened once with the Ukraine invasion and hacking into the platforms, I think, the world we live in today, no matter what the application, cybersecurity is a critical element of that. Making sure that your security infrastructure is up to spec, whether you're a traditional teleport operator or whether you're in a data center or on a standalone site in the middle of nowhere is such a critical element of the baseband and IP side nowadays that you're heavily remiss if you're not providing that or have a service integrated into that side of things. The damage that can be done is catastrophic, personally, business-wise. I mean, it's so yeah. It's hard to understate how important that actually is, but it's relatively easy to set up. There's plenty of providers out there that'll do that for you as a service, but your whole environment needs to be protected. It's not one specific element. It's the whole facility from a access standpoint, whether that be at Wi-Fi or terrestrial infrastructure or whatever. But it's it's definitely one of the main feature sets that you've got to have in place today.
Okay. Kevin?
Travis, but yeah,
I'm sorry.
That's all right.
Kevin.
I think that one of the, again, non-sexy points is that on the platform side, we're sitting on a lot of really old code bases that are really fragmented. If you want to talk about the Viasat thing, that's an old Motorola surfboard interface that was probably first put into software 25, 30 years ago. Probably doesn't have a whole lot of people who actually understand all of it. And if you were a foreign power who was interested in disrupting commercially available satellite services that are being relied on by your neighbors, it wouldn't be hard to get one of your operatives into that development team. And we've got, maybe less than a dozen providers doing this. Almost nothing is open sourced. I would say, actually, on the Starlink side, they're on a OpenWRT platform. At least the router core is open source. Now, maybe their waveforms aren't and things like that, but there is some look in. And there's some look in on OpenWRT into Motorola Surfboard as well. But again, not a lot. So as a real old school computer dork, code security is key. And the only way you get that is with peer review, with external validation, external security audits, things like that.
All right, great. I did have a regulatory question here. I know most people don't have anything to add to that. Ian, did you have anything to add to?
Just in terms of everything that you both said is absolutely right. It's important to segregate networks as well. The industry was notorious for going and installing VSAT terminals around the world that had open passwords. It was a way into complete networks. But these days, even your fridge in the kitchen, internet-connected appliances are ways into the network. So security cameras, it's rife. You just need to be vigilant the whole time and make sure that the networks are segregated from each other.
Okay, great. What is the potential for hybrid networks that combine terrestrial and satellite components, and how can teleports and data centers support these integrated service strategies in a multi-orbit environment? Travis?
I'll take one. So you have a problem with hybrid networks when you're trying to switch them out of a single point, in that you're going to have to be passing the traffic some way, which means that if you're sending it out over 5G or something like that, you still have to be in control of the flow of the traffic and the routing. So your transmission requirements go way up, and your latency could affect that depending on how far you are from the mobile base station, blah, blah, blah. The best way to probably do that is through the client premises equipment, to allow it to dynamically construct SD-WAN that doesn't rely on a central authority. The problem with that is nobody really does that yet. It's a great idea to be able to take a bit from the satellite and a bit from the 5G and a bit from this and a bit from that, and be able to control it remotely, and be able to integrate with the waveform so that you can maximize your over-the-air usage, because that determines your efficiency over the satellite, which of course is your high-cost center. It's a difficult one to design, and I don't think that there's a good network-wide design for it yet.
Okay. Scott, hybrid networks?
Predominantly for redundancy, I think is the main one still used. I think all of the points Travis raised are spot on. From the telco side of things, if you're providing hybrid networks, a lot of the complexity goes into the class of service and quality of service configuration. The SD-WAN side of things in terms of which traffic you're routing over, which network at what point, and the costs associated with that, as Travis says also. Your 5G to your terrestrial to your satellite all have very different cost bases depending on the data flows and the latencies, and session switching. If you're going from the 5G to the satellite where they land in completely different points of the world and have to link back to a cloud instance. So the sort of hard switching redundancy option is probably still the most leveraged from that perspective, but ultimately, I think as an industry, telecommunication-wide, not just satellite as a whole, but the sort of ubiquitous coverage where everything's on, the transport layer is the transport layer, whether that's satellite, mobile, terrestrial, it is going to have to become completely interoperable, but I think we're still a little away from that. And a lot of the upgrade of the infrastructure to be able to cope with that, specifically around the automation and orchestration, is still very much in its infancy.
Okay, great. Ian, anything to add to that?
So we talked this morning about our mobile phones being the ultimate consumer satellite product, but I guess it's also the ultimate VSAT terminal. And VSATs are already very unbalanced in their link budget. And when you've got a few milliwatts of EIRP available from your mobile phone, it's even more challenging. So whilst you can see that you can you could take advantage of direct sequence spread spectrum and high throughput satellites to get data down to your devices, how do you get the data back? So it sort of lends itself to this sort of concept of having a hybrid service there.
Okay, great. Last chance for any audience questions. All right. I'm out of questions. Final thoughts from each of you on multi-orbit, multi-band teleport and data centers? Travis, you want to start?
Yeah, I've got a presentation right after this about data centers and teleports, so I'm trying not to rob for myself. But the teleport game, as I would call it, used to be one of vertical integration for a service provider, right? And if you look at it historically, that's why I got into it before. That's the builds that I've set in on. It's all about somebody who's trying to control their cost structure and provide a reliable and guaranteed service. I think with the march along towards LEO and ubiquitous coverage and all of that, it becomes a much more difficult game for the teleport operator to satisfy these new business cases that have wildly different physical requirements from the same sites they've already got. So, I mean, unfortunately, I just don't think that everybody's going to make it.
Okay, final thoughts, John?
Yeah, so from, if you go back to a classic geo system, you'd have to actually add the diversity into that to the extent you need it. Whereas with a multi-orbit system, it comes with it automatically. There's diversity there. You can route through inter-satellite links, different ground stations. So then it's a different question. It's more of what do you want the system availability to be overall, the system throughput overall. So it's a slightly different, it's more the degree to which you want the diversity and availability and system throughput rather than with geo, where it was just, do you want it or not?
Okay, Ian?
Yeah, so to try and get away from repeating the same message that we all know. So we're all embracing LEO now these days. Maybe we should give GEO some love again and think about diversity there. And let's not just forget about GEO and just have a think about how we can utilize that huge investment that's there, as well as embracing the new entrants and think about that diversity a little bit.
Great. Scott?
I'm going to echo Ian a little bit actually and say I don't think GEO's going anywhere anytime soon. I know everybody likes to theorize around the death of GEO, and to be frank, they have been since the mid-90s when I joined the industry, and we're still going some 30 years later. I think what my final takeaway would be is the orbit is very application specific. You know, if we look at Starlink and we look at what Amazon are going to bring, you know, it's broadband connectivity to the masses. Would I put mission critical services that require 100 or very high availability over a Starlink service? No, probably wouldn't. I'd still be very much looking towards GEO. And I think the teleport operators and the GEO assets that are up there have still got a very big part to play in the satellite ecosystem, but the telco and service ecosystem for the foreseeable future. So ignore the doom and gloom about GEO. It's I definitely don't believe it, but you know, also don't be surprised if you see the subscriber numbers going through the roof on Starlink and Amazon, because you know, broadband services are very, you know, if you live somewhere great like, you know, central London, brilliant, but if you know you're out in the wilds, even here in the UK, Starlink's a really good service for broadband access, but you know, that's what it is. It's a broadband service. It's not a mission critical application service that's going to take everything from everybody all at once.
All right, great. And with that, we are out of time. Thank you, and please join me in thanking my panelists.